So in this example, we are finding the difference between the functions f of x and g of x. Difference means subtraction, so we're doing f minus g as far as the notation goes. F of x is the function 3x plus 4. When you're setting up function operations, you want to make sure you put stuff in parentheses. And g of x is the function x squared minus 5x plus 2. Afterwards, it's not much different from other things that you probably have done in Algebra 2. And that's just distribute the minus sign through and then combine like terms. So we'll have minus x squared plus 5x and then minus 2. There's no other x squareds. We have 3x and 5x, which makes 8x. And then 4 minus 2, which is positive 2. So this is the expression for f minus g. Okay, in this example, we have the two functions f and g, and we're asked to write the expression for the product of f times g. So, notationally, it'd be f times g, and that means we're going to take the f of x function, which is 2x plus 3, needing our parentheses, times our g function, which is x squared plus 5. Now this is multiplication, so it's just distribution. So 2x times x squared is 2x to the third. 2x times 5 is 10x. 3 times x squared is 3x squared. And 3 times 5 is 15. If we check for like terms, there actually are none this time. However, it is nice if you do put it in standard form. It does make it look a little nicer. So in standard form, the expression would be 2x to the third plus 3x squared plus 10x plus 15. Okay, in this example, we're supposed to find the quotient of f over g for the functions f of x and g of x. So, if we start off with f over g, well, our f of x function is x minus 7, and our g of x function is 2x squared minus 13x minus 7. Now, on the other examples, I said you should have parentheses as you are setting stuff up. Well, parentheses aren't really necessary for this one because there is implied parentheses on top and bottom. Now that we have that, we just need to simplify it. And this is a rational expression. And since it's a rational expression, we should try to factor the top and bottom. So x minus 7 does not factor. On the bottom, if we go to factor, negative 14x squared, the combination that adds to be the middle term is positive 1 and negative 14. Because there's a leading coefficient, we will have to do the full process of factoring. We're using the factoring by grouping, so 2x squared plus 1x minus 14x minus 7. X is the common monomial for the first two terms, giving us 2x plus 1. And in the second terms, negative 7 is the common monomial, giving us 2x plus 1 again. 2x plus 1 comes out of both. leaving us with the factor x minus 7 as well. So overall our factors are 2x plus 1 and x minus 7. We have a common factor on top and bottom, which will cancel out, giving us 1 over 2x plus 1. However, there's an extra condition for this type of problem, for the division. The division can never have the bottom function equal 0. So we have to add that additional condition on to this problem. Now the bottom function would equal 0 when either of these two original factors equals 0. So we'll just set each of the factors from the denominator equal to 0 and solve those. So the 1 would be x equals 7 as a restriction, and 2x equals 1, so we'll divide by 2 on both sides. X is 1/2. So those are our two restrictions. So as part of our answer, x cannot be 7 or 1/2. And that would be the completed answer for this problem.